you guys are in for an exciting surprise because we were super happy when we heard that we were going to get a tour at Scat Enterprises. And guess what? You guys are going to see how the crane shafts are actually being made today here at Scat. And who better than to show anybody around this place than Tom and Tommy Lieb of Scat. Gentlemen, this is exciting. Obviously, our viewers are going to be very, very excited about it. So take it away. What are you guys going to show us?
Well, today, fortunately, we've got all of the machines running to take a 230-pound round bar and make it look like either a flange or a dowel pin crankshaft. So as we go, Tom and I will take and show you how it's done. And, it ends up being a 27, 28-pound part when it's finished. So we throw away the major portion of the steel that we have. But you'll be amazed, I think, with what we're going to show you. So let's go to the first operation, which is basically over here behind us.
We'll follow you.
These are, what you see here on the pallets are round bars. That's the way we get it from the steel mill. The steel's already heat treated to the core hardness of 34 to 36. And we go into the Okuma machine here, and we'll walk over and we'll show you what we do. We're passing by here. Here's the drawings. Everything that we do is run with a drawing. The operators know exactly what it's supposed to be. This is part of the quality control sequence, but we have our we have 3 full-time engineers, and they're responsible not only for the drawings, but the programs to tell the machines what to do. And of course, this is what we're going to see. Can you stop it so we can take a picture inside?
Yeah, man.
We're going to open up the machine here and let you peek inside of what's going on. Basically, as you go inside, we're taking the bar at this point, we're facing it to length, and then it'll go through and it'll finish both ends, which are completely done then when it comes off this machine. They're not changed from here. So this is and then we'll go from here. This particular machine has 70-some different tools in it, so automatically through the programs it will change through each operation to put the dowel pins, to thread for the gland nut, to drill and tap the nose, and put the centers in it. And from here then, it will go to the next operation, which we'll walk over on the other side of the shop. But we'll show you what happens here. Now we'll walk over, we'll pass over. Thanks. We have 45,000 square feet here. We've been in this building since 1975. Our previous buildings were in Englewood, where we had collectively, when we moved, about 17,000 square feet of warehouse and machine shop. And so we've been here for, a while. And here on the shop floor, the section we're in, we have a whole cadagle, if you will, of CNC machines, which are quite amazing. Here's the next operator. Here's the next operation, and basically what goes on here, you notice that the bar was round. Now what we're doing is we turn the nose, we put the center main in, and then the rear. So this is basically the finished part. So it goes in here. Here's what the part looked like when it went in there. The first operation we looked at, all the dowel pins are in it, cut the length, all the center, the thread for the gland nut. On this end, it's faced off, that's the center, has the drill and tap for the bolt for the pulley. So it goes in here, looking like that, and then this machine takes and turns it. And then cuts out as you see there. And then if you look at the carriage, you'll see that this has 12 different tools that the computer, we told the computer what to do, and it's a good employee. It does exactly what we tell it to do. Most of the time. But we've got, well, Tommy and I are really fortunate. We've got some great employees, and they take a lot of pride in what they do, and this is good stuff.
There's an employee right here. Our shop foreman, Marty.
And then
he oversees
this
out there.
This is who runs this machine here. Okay, we're on to number 3. Woo! George, you're up. The cranks that we're looking at are the dowel pin cranks, and the operations for the dowel pin and the flange are basically the same. And over here we're making flange cranks. So we have the crank, as you saw over there, they're round. Now we're cutting the counterweights. And this is George. And this machine is going to cut the counterweight shapes. He's got to get to a position where he can open the door. In the meantime, you can see the drawings, and this tells him exactly what it's supposed to look like. You want you to see the food over there, it's going to cut. Wow. Okay. So every single crank has a different picture that
George puts up?
Yeah. This machine is just chomping away.
How long does it normally take for this machine to go ahead and go through this process?
I don't know.
I mean, when I look at the all of the different processes from start to finish, I mean, I'd be curious to see how long it takes. All the love that goes into one crank,
Right.
Yeah, there's different machines too for the different processes. This is the vertical mill here, which is cutting the counterweights. On the other machine over there, the Okuma, that's a horizontal.
Right.
So you have different machines for different operations depending on what you're trying to accomplish.
And what Tommy's talking about is horizontal and vertical is the position of the tool. You notice that the tool in this case comes down vertically.
It's like a drill press coming straight down.
And then the machine on that we looked at over there, it comes in parallel with the ground. George? George? How long is this operation?
Oh, 45 minutes.
Wow.
In that operation over there, what do you think it normally takes about how long? First one?
45 minutes.
Okay. That is wild.
So when it comes out of here, if you compare the two, it goes in there like that, comes out like that. Or maybe Tommy, you want to explain to him what the counterweight shapes, in this particular case, what we've got going on here.
Well, this is an arrow type of counterweight where it cuts through the windage inside the case very, very efficiently, and it also is very thin, so it's super lightweight. And being a flat crankshaft, it also helps with the balancing. So there's many benefits to this type of counterweight. It's easy to machine because it's flat, so you can take a nice, skin cut. But it also, like I said, it cuts through the windage inside the block.
The other thing that we've done is the section right here. This is a finished crank, so this gives you a perspective of, we've seen a round bar, we've seen it come from here to here to here, to give you a perspective of what the crank looks like. But this section here, we've beefed up, and again, this is where the customer comes to us and say, hey, it's working great, but I got more horsepower, I need more strength. So this is where we beefed the latest design, we beefed it up. We also,
Right here, this cross section here is flat.
we've also on the flange crank, originally we've gone through 4 or 5 different bolt patterns in the back, as the power has gone up, of course, Volkswagen's having a problem with keeping the flywheels on. So we've redesigned the flange several times, and this is the latest design. We use ARP bolts. It's got 8 bolts and 1 dowel pin, and so far, knock on crankshafts, the drag racers have not spun these off. This is the latest and the greatest. We've had this design now for how long, Tom?
For about 10 years.
And of course, as horsepower goes up, the more you can respond.
This is a bolt here. It's an ARP 8740, 7/16 diameter, and you have 8.
And those bolts we got ARP.
Along with 1 dowel pin here for a locator.
Good looking too. Well, like we were talking about, we put a little sexiness into the crankshaft. George, you want to get ready for the GFM? Okay, now this is the next step. This is number 4. This is the awesome. I mean, all the machining is really, interesting and stuff, but the machine that we're going to use now, the one behind me here, the blue machine, the GFM, this machine weighs 60,000 pounds. It's 6 feet in the ground on a steel frame poured in concrete with felt around it, and it's got 100 horsepower on demand. And when you see what it does, it takes, and here you can get the perspective, it takes and puts all the throws in place. So you can take it from this position here, all that metal, in here. Let's put this started.
And the difference between making crankshafts back in the old days compared to how we do it today is that the crankshaft is stationary inside the GFM machine. So the crank goes inside the cutter body, and then the cutter body itself rotates around the crank and strips the material away. You can see the cutter body right here. The crank goes inside here, and then this rotates around the crank, strips it away. A lot more efficient and faster than the old.
It's going to do pin number 1, pin number 2, number 3, number 4, and it's going to cut material from here all the way down to make this pin.
Wow.
Then do this one in less than a half hour, I think.
That's awesome. Thank you. This is incredible. Look at all the excess material coming out. These gotta be these.
Making a heavy cut now, so it really start to pour out now.
Very cool. That is awesome.
Now you notice that the chips are blue The method that we use in cutting is called climb cutting, which means that we pull the material off rather than push it off. And what that does, it takes all the heat from cutting and puts it into the chip, so that when the part comes out, it's relatively cool. Where the chip is, it's turned blue, so obviously, it's very, very hot. But that way we don't put the machine stress into the part. So, the other guys that make parts, they don't have equipment like this, and basically they put 4,000 racing miles on it, on the crank, before it ever leaves their shop. So in this case, it's not the case. And you notice that the floor vibrates a little bit. Now, one of the reasons that the machine is 6 feet in the ground is because we're in We're in, earthquake country. So if we have an earthquake with all of these CNC machines, the problem is that if the floor shifts and the surface where the machine is bolted to is changing, then it will take the machine and throw it off. So this means 6 feet of concrete, it can go a little cockeyed, but it doesn't push things away. We're making air-cooled cranks. Like the Volkswagen engine, we don't need water.
Love it.
Very good.
I like it.
Well, basically, we'll do one. Or in this case, for the Volkswagen cranks, we do an average of, like cranks, we'll do 10 at a time. Dowel Pin Cranks. When we make the Porsche cranks, like we supply worldwide the majority of the 4-cylinder Porsche cranks for the old 356s and 912s. And those we do 25 and 30 at a time. So we'll do, it's all depending on the customer and the demand. And so, the machines don't care. It's up to us to, we push the go button and they just...
So you're open 24/7 then, right?
Yeah, right. Yeah. But no, it's all about economics. And
So we started, about 10 minutes ago as far as making the crankshaft when it went in at its billet stage.
yeah.
So we're almost finished with the whole process. It's more than halfway finished, so on average it takes about 20 minutes to manufacture a crank for the GSM.
Yeah, for the Volkswagen cranks. Now the John Deere tractor cranks, like you saw there, that's 2.5 hours. in this machine. So
pretty quick, and you can see the amount of material that has been stripped away. When we originally started with the 240-pound piece of billet material, now we've cut it down to somewhere around 30 pounds.
That is something else. So from here, basically after this one, it's going to go to the heat treating for the finishing.
this machine is not cutting that. I mean, at what point in time can you take it off that later? Oh, you could take it on this. We'll take it out as soon as it's finished cutting. Right out there the next time.
Is it on? You think it's on the last drill?
Just cutting the chamfers now on the
So basically from here, you were telling me that from here, then it's going to go through the finishing process. What is that finishing process? Can you briefly just tell people, because obviously we saw how it's cut, and then from there, you said you drilled the
oil holes.
The oil holes.
Yeah, for both the mains and for the rod journals. The crank has been taken over to our oil hole department, and we have different fixtures that holds the crank in place, and then we come down using a Bridgeport, you know, a traditional way of drilling, and the fixture holds the crank at the different angles so that we can drill the holes to where we want them.
Right.
So after we finish with this GFM process, we'll go over the oil holes. As you can see, the crank is coming out of the GFM right now.
Well, we talked about the difference in color between the finished crank being nitrided and the gray color versus the machine color of the virgin metal, if you will. And like Tom says, it gets oil holes. As soon as that's done, it's deburred and polished, and then it goes out for the second heat treating, which is the stress relief. And what that does is that stabilizes the metal again after we've taken and cut it all. Right, you know, it can have a little bit of a whoop-de-doo in it, and so that's stabilized. From there, it comes back in and shot peen. We finish grind it, and then we balance it, and then it goes out to the final heat treat. Put the keyways in it, and then it goes out to the final heat treat for the nitriding, the hardness of the journals. Comes back, final inspection, boxed up, and shipped to a racer that's going to go 120 miles an hour, whatever he's going to do.
That is cool. All right. So it's awesome. And it's incredible the amount of work that goes into it, the amount of love. I think, you know, for someone like myself that you see this crankshaft come out of a box, to see all of this and everything that you guys put into it, it definitely opens your eyes to the amount of care and love and technology, obviously.
A lot of love here, a lot of love, as you can see.
No, that's
Feeling it, man.
That is awesome. Well, very cool.
So anyway, that's the story of how, you know, a crank is born. You were wondering how hot it is. You know, it's toasty, but it's not blue and red and burning and so forth.
Right.
So it's all the temperature went out in the chips. That's cool.
So there you have it, folks. Pretty exciting stuff. You guys, you know, I mean, we're going to post some other videos. We just wanted to go to you guys live so you can actually see this. We were excited, and it's a pleasure and an honor to actually be guided by these two gentlemen. And so, you know, stay tuned. We're going to go ahead and post some more exciting videos of some of the other processes. I think you guys said you got stumps that we get to see. So stay tuned.